Chapter corresponds to Chapter 20, which is elasticity of demand and supply. And this particular chapter deals with looking at the curve and measuring the demand and supply curves to see how responsive consumers and producers are to changes and movements along the curve. Okay, the big idea with elasticity is determining how responsive consumers are to changes in prices. We know that consumers buy more when prices go down and less when prices go up. But how much more or less, and does it matter to whom? Elasticity provides us with an answer. The equation that you guys need to memorize for price elasticity of demand is percent change in quantity over percent change in price. This is used to determine consumer sensitivity to changes in prices. So look at our first graph. Here we've got a coefficient of 0.5. What does this mean? It means that the bottom, right, changed more than the top. So price changed a great deal relative to quantity. We call that sort of demand inelastic. Quantity changed half of what price did. That's what our coefficient tells us. So we move our price and quantity changes half as much. Our coefficient tells us 0.5, and as you guys remember, that's an inelastic coefficient. Here we see the equation just expressed as you typically might find it on a graph or in an essay or on a test. Different ways to look at our equation. We can do our basic percent change quantity in the product X over percent change price in X, or we can find the elasticity by doing the percent change quantity demand of X, original quantity demand of X, divided by change in price of X over original price of X. So that's the basic formula for determining percentage change, right? We eliminate the minus sign because it's not necessary here. We always have an inverse relationship between price and quantity. It never goes in a different direction. When we look at cross elasticity and income elasticity, the coefficient will matter. Here are some basic interpretations of elasticity. Elastic demand, 4% change in quantity was caused by a 2% change in price. The price change comes first. 2% change in price, 4% change in quantity. Elasticity coefficient of 2. Simply stating that, in simple terms, quantity changes twice as much as price. And as we're going to see, this would be the point to lower prices because the change in quantity will exceed the change in price when we apply our total revenue test. Inelastic demand, percent change in quantity is less than percent change in price. We have a coefficient less than 1. Unit elasticity, percent change quantity, percent change price move at the same pace. Let me rephrase that. They're equal. So the percent change in quantity gives you the exact same percent change in price. The coefficient turns out to be 1. What determines elasticity? Inelastic versus elastic? Well, substitutes. A lot of substitutes make for a more elastic curve. Less substitutes, people aren't going to change their buying habits as much because there's no other good options. Proportion of income. When something is cheap, relatively inexpensive, if it goes up in price 10%, say something that's 20 cents goes up 10% in price. Now it's 22 cents. Big deal. I'll probably still buy it. Versus something that goes up in price 10%, that's $40,000, like a car. Now it's $44,000. That's kind of a big deal for most people. Luxuries, is it something I would like to have and be kind of cool versus something I need? And time. Demand becomes more elastic with time as more substitutes come available. Extreme cases. A perfectly elastic demand and a perfectly inelastic demand. The inelastic comes first here. It's straight up and down, meaning that price can change, right? And consumers do not pay any attention. They always buy the same quantity. So we'd have quantity as 0 over price. And an inelastic demand is a coefficient of 0. Perfectly elastic demand would be infinite because here consumers don't buy anything if the price changes at an infinite quantity. So we'd be dividing by 0 on the bottom. Here are two extreme cases. next few slides, I want you to kind of walk through. I'm not going to put audio in all of them. But the idea is that when prices are low, total revenue is low. As we raise prices, total revenue rises till we hit a point where raising prices isn't a bright idea anymore. That's at unit elasticity. The bottom lower right-hand portion of the demand curve is inelastic, as even if the curve itself is generally elastic. As prices go up, revenue goes up, and we have an inelastic demand. When we go too far and we hit unit elasticity and prices start to engender a larger percentage change in quantity, in other words, price goes up 10%, quantity falls 30%, we've gone too far. We've gone over the top of the apex of the curve, as you'll see, and we don't want to raise prices any further. We found the sweet spot on the bat. We found unit elasticity. Revenue works. When we raise our price and make more money, we have an inelastic demand. Price times quantity is total revenue. Price changes more than quantity, we have an inelastic demand. When we lower our price and make more money, we have an elastic demand. Conversely, if we lower our price and lose money, we have an inelastic demand. If we raise our price and lose money, we have an elastic demand. So the total revenue test is just total revenue equals price times quantity. Whatever percent change is larger tells us which direction our revenue will be headed, depending on what we do with prices. Right, we've got some fun here. Remember our friend Mr. Cross Elasticity?
Hi, kids. How you doing today?
Good, Mr. Cross Elasticity of Demand. What's going on?
Well, I want to tell you what I'm all about.
What are you all about, Mr. Cross Elasticity?
Do you remember when Mr. Kopitsky talked about figures? And he talked about calculating coefficients of cross elasticity in the catalog?
Vaguely. Can you tell me more?
Yeah. Well, there's a thing called...
Okay, I can't do it anymore. Cross elasticity. Percent change quantity demand of good X over percent change in the price of good Y. So we change the price of Y. Peanut butter. And we see what happens with good X. Jelly. Okay? Now, what we would suspect with peanut butter and jelly is that a positive increase in price, say 10%, would result in some sort of decrease in the quantity sold of good X. Let's say 20%. Okay, that would give us a coefficient of -2. An elastic response, but here the sign matters. Okay, a negative sign means goods are complementary. Price goes up for peanut butter, quantity demanded for jelly goes down, right? Up, down gives us a negative sign, they're complements. A positive sign would give us substitutes. Coke and Pepsi. The price of Coke goes up, the quantity demanded of Pepsi goes up, plus, positive sign, they would be substitutes. And the number would tell us whether they're an elastic or inelastic coefficient of substitution or complementariness. I think that's a word. Demand. Here, it's quite simple. We change income, and that's easily measured. National income is measured on a regular basis to determine macroeconomic indicators, and it has the microeconomic applications of looking at inferior and normal goods. Normal goods move in a direct relationship with income. Income up, change in quantity demanded up. Cars, movie tickets, meals, new clothes, new shoes, most things that you buy in a store are normal goods. So income goes up, plus sign, percent change in quantity demanded, plus sign. It's a normal good, positive. If income goes up and percent change in quantity demanded falls, we get a negative sign, a positive and a negative, or a negative and a positive. These are inferior goods. Goods that you tend to buy more of when your income falls. Generic meat, Spam, retread tires, Goodwill clothing, things like that. So we can kind of gauge those sales on income in a reverse relationship. As you might expect, we can calculate price elasticity of supply. Price elasticity of supply is found simply by taking the percent change in quantity supplied of good X over percent change in price. In other words, how sensitive are suppliers to change in the price of good X? Do they respond with a flood of merchandise on the shelves? Are they eager to take advantage of higher prices? And can they do so quickly? Or are they stuck? As you'll see in the next slides, time is a crucial factor for increasing quantity based on changes in price. See what we call the market period. We talked about Hurricane Matthew, and we talked about water on the shelves and hoarding. Well, there's nowhere to get more water in a very short period of time. It's stuck. Whatever the quantity is of that water during the market period on the shelves, that's all there is. So price is going to be driven by demand. A giant increase in demand is going to jack price way, way high. In demand. And obviously the price goes up dramatically. As we'll see in the next couple slides, though, as time goes on, suppliers are more able to deal with shortages, ramp up production at factories, increase shipments, put on a third shift driver to haul product to market, and that sort of thing. And you'll see that over time we get a more elastic response with an increase in demand. Short run here becomes fairly elastic. And you see here in the long run we get a highly elastic response. So an increase in demand leads to a slight increase in price and significantly more quantity. Well, I hope you've enjoyed elasticity. Remember, there are certain things that we do with elasticity. We've looked at taxation, we've looked at price ceilings and floors. If you're stuck on those, review those sheets and packets that we worked on for challenges. Also, go back and look over some of the videos and look over your questions on the formative multiple choice tests. Those will be useful for you in determining how to draw those and how to gauge those particular curves.